Okay, so tonight we're going to discuss the how data is stored in Ethereum and do a little contrasting with Bitcoin. So Bitcoin is really, it stores essentially your balance. This is an article, by the way, that I've looked at. The first by he calls himself Vasa. His Mr. I'm going to butcher his name if I try to pronounce it, but Mr. Saini, um, and he talks about Bitcoin, how basically when you do a transaction, anything less than one Bitcoin that you have, let's say you have a Bitcoin and you're paying someone half a Bitcoin, must be for something pretty expensive. You give them the half, and then the other half is rerouted back to your account. You think you had what you see as the balance, but this is essentially how it works. Ethereum is a bit more complex. They use what they call Merkle trees, which are basically a tree. The What is stored on the blockchain is the root of these trees that have where basically you start at the information, and then it's hashed, and then the hashes are combined, until you get to the root. So they have three different ones: the transactions, the state, and the receipts. The state is essentially the state of the blockchain, and it's sort of a hash of everything in its balance, everyone their balances. Transactions are the way it describes a transaction back to who went, what went where. Let me see, because I just looked that up. Okay, so transaction, it represents the transaction vector, so the nonce, the gas, the transfer. This is an answer from Ethereum Stack Exchange. Transaction signature values. The receipt is basically the result. So you have three different tree-based databases, if you will. The transaction trie, the receipt trie, and the state trie. Now, tied into that is the storage trie. That's where your smart contracts are stored. So you can see how it's much more sophisticated, and how it can do a lot more than Bitcoin. And you see the little chains. Someone in one of my in a group I'm in is an artist, and he did a wonderful little drawing of his concept of a blockchain, which was really cool. His specialty is actually doing drawings of artwork. Of cars rather. And he's a pretty amazing artist. There are several amazing artists in the group. Anyway, back to this. The Bitcoin model has scalability. It has privacy. It's a bit more private. So if you use now that's interesting, because your wallet has one address, but I have seen things where, and maybe it was on the Avalanche chain, where every transaction had a different address. The Ethereum is more of an account balance model. So it's the benefits of simplicity and efficiency. So there are some weaknesses. Now, obviously, some of the newer chains try to address these things. There's one we saw, multiple ways of validating, and I know Ethereum 2.0 is going from a proof of work, which is similar to Bitcoin, to a proof of stake, which uses less resources and so on. And most of the new exchange you see use proof of stake rather than proof of work. I think, proof of work is probably, the older way of doing things. So if you look at the tries, the state trie, it's kind of the global state, a key value for every account. And the key is identifying the value, nonce balance storage code hash, account details of the Ethereum account. And the storage trie is where your smart contract data is. So remember, there's all that data when you compile a smart contract that would be stored in the storage trie, and the transaction is the list of transactions. That's a transaction trie. So if you look at the blockchain, so let's look at some. So if you look, you have extra data, gas limits, and the actual values. So you're storing roots. You're storing essentially hashes of hashes, and what that avoids is having too much data actually on the blocks. Now there are two databases used. ROC, it's mainly, I believe it's used by the parity people, the people who did Polkadot. LevelDB is what you're going to see in your Go-based Ethereum chains. So and you can see. So let's look at this here. I think I have it. Let's see, this one, I think. Let's see if I can. So you could see here, this is what we were looking at last night, and you could see the receipt data, all that. And if we look at, see if I can bring where truffle is hiding. See what this is. Is that, no? Well, that's yeah, is that truffle? Yep. Okay, so truffle, you can see this is a block, and let's see, no, this is a transaction rather. Let's go to blocks and look at a block. It's only one transaction, it looks like. And you can see the transaction data on there. So this was contract creation. How much gas, excuse me. So, and with the contracts, let's see if we can see if it's going to show that here. You can see the storage, the creation. Let's go back to one that has, I think Simple Storage actually has, it has stored data, which is what you store, but it also has some methods, but we're not. And you can see those. Let me see. Yeah. If we do, what is it? Do I have instance? So you can see the, and let's see something. And that's just the hash of the account. I'm trying to remember. I think it's like, you can use the account to pull up all the information. Let's see what we can do here. Accounts. So here's one account. How many transactions? Let's see if we could. That's the keys. I want to show more information on it. The balance. Let me see something. If we can. So looks like it's not as easy to show it as I was hoping. But you have all this information. So again, you've got 3 different types of stores. Your let me go back to this here. You got the state, which is your accounts, essentially. Your storage, which is your contracts. The transactions, which, again, we talked about how that's basically information about the, I guess you would say, the mechanics, and the receipt, which is the result of the transactions. We can delve more into the database, and again, you have LevelDB, you have RocksDB, and they implement the actual trie-based data structure that Ethereum uses. So anyway, hopefully this has been helpful to you to understand how the data is stored. And he goes in here and actually shows you examples of the information. Now, since I'm not running Geth, I think what we probably do need to do is look at it in Geth, because that's where you have a lot more power than what we got going on here, at least from what I can tell. So you can see different things, the blocks. This doesn't get into all the details that you would see if we were in Geth. Now, I imagine you can probably make those calls in the Truffle UI. So anyway, again, hopefully this has been helpful to you. If it has, please give a like. Please subscribe, ring the bell so you get notified, and tell a friend. And I will see you next time.